Hello everyone, and welcome to the video on trig functions of other angles. So we're going to be looking at what happens, how can we evaluate a trig function when what we know is that the terminal side goes through some point somewhere in the coordinate plane. So our skill objectives for this video are 1. Calculate trigonometric function values for non-acute angles. Number 2, determine the reference angle for a non-acute angle. And 3, calculate the trig function values for quadrantal angles. Quadrantal angles are the angles whose terminal sides are on the x or y axis. The conceptual objectives for this one, the first one is that we understand that right triangle ratio definitions for trig functions are consistent with the definitions for trig functions of all angles in the Cartesian plane. In other words, the whole SOHCAHTOA thing will work for other angles as well. Number 2, understand why trig functions are undefined for quadrantal angles, why some of them are. And the third thing, understand that the ranges of sine and cosine functions are bounded, whereas the ranges of the other 4 trig functions are unbounded. To start out with, we're going to look at what happens when we have an acute angle, how that works when we're talking about something in the Cartesian plane. So what I have drawn here is an angle. The terminal side goes through this point xy. Now, what I'm going to do with this is I'm going to go and drop a perpendicular from xy, a line perpendicular to the x-axis. So it's going to come like this, it's going to drop right down there, and it's going to form a right angle. Now, because of this, we now have a triangle. We know that the distance that we go from along the x-axis here, that distance, that is going to be x. And the distance that we have going up, that length is y. Now the last length that we have to find in terms of the this side is we want to find the distance that xy is from the origin. So we want to find that length. And that length, what we're going to call it, is going to be r. And r, by looking at this, because we have a triangle, we know that r squared is going to be equal to x squared plus y squared. Or we can look at it as r equals the square root of x squared plus y squared. Regardless of all of this, we know r is going to be greater than 0. You have to keep that in mind. R is always going to be a positive number. So now when I look at this, I have a triangle, and I can now go through and say that the sine of theta is equal to opposite over hypotenuse, so that's going to be y over r. And the cosine of theta is going to be the adjacent over hypotenuse, which would be x over r. And the tangent of theta comes out to be y over x. So how does this affect when we go outside to an angle other than one that's in the first quadrant? Well, I'm just going to draw one here that will have the terminal side in quadrant 2. Okay, but this could be one in quadrant 3 or quadrant 4, either one. But we'll put it in quadrant 2. So there's our initial side, and our terminal side is going to be here. And there's our point. We'll call that will be xy again. And our angle is right here. That's theta. And we have this. Now what happens on this? We can do the exact same thing that we did with the acute angle over here. We can drop, like here we dropped a perpendicular from the point xy. We can do that in this one too. We just drop the perpendicular, and we now create a triangle. And we know that this length can be represented with y, and this can be x, and that will still be r. And so when we look at the triangle, we have this angle right here. Well, this angle, we can use the SOHCAHTOA relationships with this right triangle, and that can get us to a sine, cosine, and tangent of this angle, but that is also going to be the same as this one. So I end up here that the sine of theta is going to be the y coordinate over r. The cosine of theta is going to be my x coordinate over r. Now keep in mind, x is negative here. And the tangent of theta is going to be y over x. So what you see here is that these trig functions can have negative values. Sine, cosine, tangent can be negative, and they can be positive. Let's take a look at our definition here. We're going to let xy be a point other than the origin on the terminal side of an angle theta that is in standard position. Let r be the distance from the point xy to the origin. Then the 6 trig functions are defined as follows. The sine of theta is going to be y over r. The cosecant of theta is going to be r over y, where y does not equal 0, because if y was equal to 0, this thing would be undefined. The cosine of theta is going to be x over r. The secant of theta is going to be r over x, again, as long as x is not equal to 0, because then secant would be undefined. We'd have division by 0. And then tangent of theta is going to be y over x, where x does not equal 0. If x is equal to 0, undefined. And the same thing with cotangent. Cotangent of theta is going to be x over y, and again, where y does not equal 0. Now, we don't have to worry about r being 0 because we have said that xy is going to be a point other than the origin on the terminal side of theta. In order for r to be 0, the point that we would have would be the origin. And so r is always going to have a value. And we have to remember these relationships again, that r is equal to the square root of x squared plus y squared, or that x squared plus y squared equals r squared. Regardless, we always want to remember that r is going to be a positive value. Let's take a look at this example here. We have a terminal side for an angle that goes to the point negative 12, 5. And I want to find the sine, cosine, and tangent of theta. Well, we know that this distance right there, that is going to be r. The distance from negative 12, 5 to the origin is going to be r. And so I know r is equal to the square root of negative 12 squared plus 5 squared, which equals the square root of 144 plus 25, which is the square root of 169, which does equal 13. So I know r is equal to 13. And therefore, since r equals 13, I know that the sine of theta, which is y over r, is going to be 5 over 13. I know the cosine of theta, which is x over r, is going to be negative 12 over 13. And I know the tangent of theta, which is equal to y over x, is going to be negative 5 over 12. Here is a second example. We're going to have a terminal side that goes to the point negative 3, negative 5. So the first thing we do have to do is identify what r is. Well, r is the distance from negative 3 to negative 5, the point negative 3, negative 5, and the origin. So what I'd like you to do right now is pause the video, and I want you to find what r is. Come up with r. Simplify the square root as much as you possibly can. Okay, welcome back. When you did this one, you should have come up with r equal to the square root of 34. It's really going to end up being r equals the square root of negative 3 squared plus negative 5 squared, which when I square negative 3 gives me 9, and when I square 5 it gives me 25. And so I get the square root of 9 plus 25, which does equal the square root of 34. So now what I can do is I want to find the value of all 6 trig functions of this. So the first thing I'll do is I know that sine, I'll do sine of theta is going to be the y over r. So I'm going to get negative 5 over the square root of 34. Now, remembering on this that we don't want to have a square root in the bottom of the fraction, we'll multiply top and bottom by the square root of 34. And so I get negative 5 square root 34 all over 34. What I'd like you to do right now is pause the video, and I would like you to identify the other 5 trig functions for theta. Welcome back. You can see I've completed these as well. The cosecant, we had that the sine was equal to a negative 5 square root of 34 over 34. Our cosecant, which is the reciprocal of sine, so it's going to be r over y, came out to be negative square root 34 over 5. The cosine, which is x over r, comes out to be negative 3 over the square root of 34. And when I rationalize that denominator, it does give me negative 3 root 34 over 34. The secant of theta, which is the reciprocal of cosine, so it's going to be r over x, is negative square root of 34 divided by 3. Tangent, which is y over x, comes out to be negative 5 over negative 3, which, when you simplify it, gives you a positive 5/3. And cotangent, which is the reciprocal of tangent, comes up to be 3/5. If you do have any mistakes, if you made any mistakes, please pause the video and double check what your work and see if you can identify what the error was. Otherwise, or if you can't find that, make sure you make note of that to ask in class. Otherwise, we'll go on to our next example. In this example, we're going to have our terminal side is going to go through the point 0, negative 3. So what we're looking at here, when we have it in standard position, you'll notice that the initial side is here and the terminal side just is on the negative y-axis. So we go through that, and from this it's very easy to see, since r is the distance that we are from the origin, between that point that's on the terminal side and the origin, I get that r is equal to positive 3. Remember, r is always going to be a positive value. And so in this problem, I know sine of theta, the sine of theta is going to come out to be y over r is negative 3 over positive 3, which when you simplify gives me negative 1. The cosine of theta, which is x over r, is going to give me 0 over 3, which is 0. The tangent of theta is going to give me, which is y over x, gives me negative 3 over 0, but that, when we divide by 0, that is undefined, so tangent is undefined here. The cosecant of theta is going to be the reciprocal of sine, so it's going to be 3 over negative 3, which again equals negative 1. The secant of theta is going to come out to be, it's the reciprocal of cosine, so I do get 3 over 0, which again, that is undefined. And then the cotangent of theta is going to be x over y, so I'm going to get 0 over negative 3, which equals 0. So you need to recognize in this that we are going to have issues with the trig functions when we are dealing with one of these quadrantal angles. When you're dealing with an angle that is on somewhere whose terminal side is on the x or y axis, because on those points that are there, you're going to either have an x coordinate or a y coordinate that is 0. And because in the trig functions there are sometimes when I'm dividing by that x or y, I would have a division by 0. So in that situation, that's when we're going to have undefined trig function values. Another thing you might notice from this in terms of sine and cosine is that if a point is on if the terminal side goes through a point on either the x or y axis, then the value for r at those points is going to be either that x or y coordinate. In this case, it was 3 for that value on this one. But the thing that happens on that is that when we take the coordinate, like we did with the sine function, right, the sine one right there, when we took the ratio, the y over r in that case, we came up with negative 1. And you should recognize that in terms of the sine values, that negative 1 is going to be the lowest possible sine value that you could have, because of the fact that that's going to be when if it's not on that angle, if our terminal side was not on the y-axis, any place I move outside here, the the y coordinate is going to be closer to 0 than -3, and therefore I would get something that is closer to 0 than -1. The same thing goes if I was sitting on if I was going through the point up here on the positive y-axis. In that situation there, the largest I would get would be a +1. And so the sine function itself is bounded between two values, 1 and -1. Cosine is the same way. Cosine, if our terminal side goes through a point on the positive x-axis, in other words, the terminal side lies directly on top of the initial side, then the cosine of that angle is going to be 1. And if it's over on the negative x-axis, the cosine of that angle would end up being -1. So what we have with this is that the ranges of the 6 trig functions are as follows. The sine function is always going to go between -1 and 1. Same with the cosine function. It is always going to give you a value between -1 and 1. Now, what's interesting about this in terms of the secant and cosecant is what happens with them. You'll notice that in terms of the ranges here, what we're not going to get are the values between -1 and 1. In other words, we're going to get everything from -infinity to -1 and then from 1 to +infinity. Those will be the values for cosecant. And the same thing is true for secant. So it's kind of like the values that are part of the range of sine and cosine, when we deal with its reciprocal, those are the values that we're not going to use, and the range of the reciprocal is going to be pretty much every number that's not part of the range of sine and cosine, but we do have to make sure that we do remember to include the 1 and -1 as part of the ranges of secant and cosecant as well. The range of the tangent function is going to be all real numbers, and that's going to be also true for the cotangent function. Part of the reason for the fact that we have so much, and we go in terms of these 4 trig functions here, that we do go off to positive or negative infinity, are because those are the 4 trig functions where we could have a possible division by 0. And what you should remember from our rational function unit was that when we had that division by 0, we had a couple things that could happen. Either a hole, which has happened when we had a common factor, or we also could have had a vertical asymptote. And the behavior that the tangent, cotangent, secant, and cosecant exhibit is classic vertical asymptote behavior, where we're going way up off to positive or negative infinity at times. Now what we're going to do is take a look at what's called a reference angle. A reference angle is helpful for some people in terms of identifying the sine, cosine, and tangent of an angle. And what a reference angle is, it's when we place an angle that is in standard position. So it's an angle from 0 to 360 degrees or 0 to 2 pi radians. And when it's in standard position, what we have, well, its terminal side must lie in one of the 4 quadrants. In other words, it can't be a quadrantal angle. Then there exists a reference angle, which we're going to call alpha. So I'm going to use that symbol right there, which is alpha, which is an acute angle formed by the terminal side of theta and the x-axis. Now, in some instances, depending on when you're in quadrant 1, like we have in this example here, we have a terminal side, it's something that's in quadrant 1. In this instance, theta is also its own reference angle. So what I have in this, if I look at this rotation right there, that would also be alpha. So if we're in quadrant 1, the reference angle and alpha are the same. If we're in quadrant 2, like we are right in this one right here, remember what's happened, that the reference angle is formed by the terminal side. It's an acute angle formed by the terminal side and the x-axis. It does not say it has to be the positive x-axis. So in this case, this angle right here, that would be our reference angle. That's alpha. When I am in quadrant 3, so we're right down in this one right here. Again, our reference angle is going to be formed by the terminal side and the x-axis. And so what we get for our reference angle is that angle right there. And then for quadrant 4, the last one, our reference angle is going to be right there. Now, one of the things we're going to ask you to do on this is we're going to ask you to go and we're going to give you an angle. We're going to want you to identify the reference angle. So to start out with here, when we are in quadrant 1, as we are in this part right here, when we're in quadrant 1, I know that because the angle theta itself is its own reference angle, I know that alpha is going to equal theta. Now, when I'm in quadrant 2, when I'm in quadrant 2, remember this angle right there, that's our reference angle. And so when I'm in quadrant 2, I know alpha is going to be 180 degrees minus theta, or alpha is going to be pi minus theta if we're in radians. When I'm in quadrant 3, this portion right there is alpha, and alpha is going to be theta minus 180 degrees, or alpha could also equal, if we're in radians, theta minus pi. That would be our reference angle. And if we are in quadrant 4, in this case right here, that's the angle, that's our reference angle alpha. In that instance, then alpha is going to be 360 degrees minus theta if we're working in degrees, or alpha is going to be 2 pi minus theta if we are dealing with radians. Let's take a look now at finding a couple reference angles. In this case, let's look at example 1. We have 142 degrees. Well, 142 degrees is in quadrant 2. Okay, I know because 90 degrees is at the y-axis, and 180 degrees would be the negative x-axis. So 142 degrees lies between 90 and 180. And so I know we're in quadrant 2. And so therefore, by our definition, I know alpha is going to be 180 degrees minus 142 degrees. And when I do that on the calculator, or just making that calculation, I come up with that alpha is equal to 38 degrees. Now let's look at number 2, 7 pi over 6. Well, in terms of, we know that 180 degrees is the same as pi radians, and so we should recognize that on the negative x-axis that's going to be pi, and 7 pi over 6 is a little bit further along than pi. That would be, pi would be like 6 pi over 6. So 7 pi over 6, I know that 7 pi over 6 is, this angle right there, is in quadrant 3. And so to find that reference angle, I know alpha is going to be 7 pi over 6 minus pi. Now I do want to think of that as pi over 1. And so I have to get that common denominator, so I'm going to get 7 pi over 6 minus 6 pi over 6. And the result will be that alpha does come out to be pi over 6. Let's look at number 3, 9 pi over 5. 9 pi over 5, it's a little bit trickier, but you should recognize that 1 full revolution is going to be 2 pi radians. Well, 2 pi would be 10 pi over 5. And so we have, this is pretty close. So I know in this case that we're going to deal with that theta, that 9 pi over 5 is an angle that is in quadrant 4. And so therefore I know alpha is going to be 2 pi over 1 minus 9 pi over 5, which will be 10 pi over 5 minus 9 pi over 5. And so in this case, that comes out to be pi over 5. My reference angle for 9 pi over 5 is pi over 5. And the last one we have is 318 degrees. 318 degrees is, again, that is an angle that is in quadrant 2. We can recognize that pretty fast. And so to get that one, I know alpha, the reference angle, is going to be 360 degrees minus 318 degrees. And when I do that calculation, I'm going to come up with that alpha is equal to 42 degrees. This does conclude the video for section 4.3. Remember that this is the last video that you're going to have to do before break, and that we do have a quiz that will take place on Wednesday and Thursday before break. So with that, I hope you are comfortable with this. Please make sure to note any questions that you have in your notes, and make sure to ask me when you are next time you're in class. Other than that, I hope you're having a good weekend, and we will see you on either Monday or Tuesday. So we will see you at our next class.